Hello everyone and welcome back. In our previous video, we have seen how to set up a very simple basic Spring MVC application without much efforts using Spring Boot. This video is going to be a very detailed one where I will try to explain each and everything in a configuration and code side. So if you want to access some specific topic, you can choose it from the chapters link given below. In this video, we will continue with our previously created application and work on these three modules. We will create register, login, and dashboard modules. We will not implement Spring Security as of now, but when we are going to cover Spring Security in our future videos, then we will use this application to implement the same. So without any further delay, let's begin. In our application, we need some kind of data store for saving the user information, which will be used for authentication and displaying on the dashboard page. So we will add two dependencies for that. The first dependency is Spring Data JPA. It will help our application communicate with the database and perform various database related operations. The second dependency that we will be using is H2 database. This is the best database option for anyone who is learning from their local systems because it can run in memory and at file system levels also. And you do not need to install any heavy database softwares. One more dependency that we will add is Lombok. This will help us in reducing a lot of boilerplate code in our entities or DTOs. So these are the dependencies. Once added, we just need to refresh the pom.xml and it will download the required jars in your project. Next, we need to configure the database in our properties file by providing JDBC URL, driver class name, username, password, and few more details. Let us try to understand all these details from the properties file itself. The first property is data source URL property. In this, we will give the complete JDBC URL of the database. Let us break it down further. Spring.datasource.url is the key which Spring Boot will look for to identify the database details. JDBC specifies the type of database connection. After that, name of the product, which is H2 in our case. And in the end, here we specify where to store the data. In this case, we are storing all database tables in a file which is present in home/data directory. And the name of the database is userdb. Next property is driver class name. This indicates the driver class in JDBC drivers jar, which will be responsible for actual database connection. The next two fields are username and password. This you can specify based on your needs. The default super user in H2 is SA. The next property is Spring JPA database platform. Now every database has its own SQL dialect. It is the way database uses SQL to interact with the data. Even though it is SQL, which is a common standard, but still there are minor deviations in every database in the way they have implemented SQL. When we use any ORM framework, internally it generates all the JPA related operations to native database queries to execute. This particular property tells the underlying ORM framework to use a specific type of dialect so that when ORM framework internally generates the SQL queries for a specific database platform, it can take care of various factors such as performance and compatibility. Next property is H2 console enabled. If it is set to true, then we will be able to access the H2 database from our browser. So in our case, we want to access H2 database tables. Thus the value of this key is true. The next and the last property is Hibernate DDL Auto. In Spring Data JPA or Hibernate, we create entity classes which represents a database table. This property will help the ORM framework to keep the entity in sync with database schema. There are different values that we can set for this property. In our application, we have used update. This value tells Hibernate to automatically update the database schema based on the entity mapping. It will make changes to the table to match the entity mappings defined in our application. The other possible values are create, create drop, validate, etc. Please let me know if you want to understand all these values in detail, then we can make a separate video on these properties as well. With this, we are done with the database configuration required in our application. Now Spring Boot will parse all these configuration and configure our database connectivity using Spring Data JPA. Now let us see what all components we will be developing in this application. First, we will create entities which represents table in the database and a repository interface to utilize the Spring Data JPA. Then we will create service layer which will interact with the repository and process the request to return required responses back to the controller. After service layer, we will create three different controllers, mainly for registration, login, and logout. In the end, we will create all the required views using HTML and Thymeleaf. So now let us start with entities. This is our user class, which will represent a database table. To make it mapped with that table, we will be using two different annotations. First one is @entity and second one is @table. In this, we can specify the actual database table name to which this class will be mapped to. Additionally, we will be using few annotations from Lombok to reduce the boilerplate code. So here we are using @data, no R constructor and all R constructor. The first column in this is ID, which is annotated with @ID. This shows that the columns represent the primary key of that particular table. Its value is mostly auto-generated, so the strategy to generate ID value can also be defined here using @generated value annotation. We will be accepting first name, last name, email, and password from the user during registration. So all those fields will be mapped to this entity, and all those fields in the entity class will be mapped to different columns present in the database table. I hope you are clear with the entity part. Now let us move to the next component, which is repository. A repository will be an interface in Spring Boot which will act as a manager of entities. It will be responsible for handling all the database related operations of an entity. So every entity will have a separate repository of its own. This is user repository interface. To make it managed bean and a manager of entities, we need to annotate it with @repository annotation. Now to utilize the Spring Data JPA feature, we will need to extend one of the existing repository interfaces. In this example, we will be using JPA repository. There we need to provide two arguments. One is the entity that we want to manage with this repository, and second one is data type of the ID field of that particular entity. So here we have user as entity and long as the data type of ID field. Using this repository, we will be able to perform all CRUD operations in entity without explicitly writing any native queries or JPQL. CRUD stands for create, read, update, and delete operations. Now we will use this repository mainly for two operations, registration and login. During registration, we need to save the complete state of entity into database. So for that, we already have a save method in one of the parent interfaces of JPA repository. In that case, we do not have to write anything at all in our repository. For login, we need to check if user exists with the provided email ID and password. So for that, the most basic solution would be either write a native SQL query or write a JPQL query. Both the approaches are feasible here, but there is no fun doing in that way. We want to utilize Spring Data JPA to make our application less coupled with database. If we start writing queries in our repositories, that will only make it more tightly coupled with the database. So to do this, we are going to use a functionality of Spring Data JPA where we will define a method in repository interface by following some convention. Then Spring Data JPA automatically generates corresponding query based on the method name. So if our native query is select star from user details where email is equal to some email and password is equal to some password, we will create a simple method definition in our interface, find by email and password. So this method will do exactly same what we were achieving using the native SQL query. Here you can see we have not written any SQL code in our Java application. That makes it loosely coupled with the database. Here in this method definition, where we have find by email and password, we have to pass two different parameters. One is for email and other one will represent the password. And automatically Spring Data JPA will convert this particular method definition into the native query which we have just discussed. So that was it for the repository as well. So here you can see we have to write minimum code to interact with the database from our application. Now let us move to the next layer in our application, which is service layer. Service layer will be directly interacting with repository. As per the software development principles, we should always code for the abstractions. So before writing the actual implementation of service class, let us define an interface where we will define what all features will be provided in the implementation. So this is the service interface and we have two features. One is to save the user details during registration and the second is to validate the user based on email and password provided. Now let us implement this interface and provide the implementation of both the features. This is our user service IMPL class. Let us annotate it with @service, which will mark this class as a managed bean in Spring Framework. Now let us implement the user service interface. Now we need to provide implementation of both save as well as validate user method defined in the user service interface. Before that, we need to inject the repository instance using @autowired annotation. As the user repository interface is also a managed bean because we have annotated it with @repository, then Spring will automatically inject this dependency into service implementation. Now let us see the save functionality. It is very simple. We just need to call the save method on user repository and pass the entity object as an argument. This operation will return the saved entity. For login, this validate user method will be used. In this, we pass email and password to the method created in user repository, which was find by email and password. It will check if the passed information is available in the database and in the mentioned columns and return back that particular entity. Now, before we continue, let us just summarize what we have done till now. We have started with the pom.xml changes where we have included H2, Spring Data JPA and Lombok dependencies. After that, we have discussed the complete database configuration in application.properties. And after that, we have done entity creation to map the database table with Java object for storing the user details. After creating entities, we have created the repository interface, which will act as a manager for all database operations related to that entity. Just now we have created the service contract using interface and implementation of that contract is provided in user service IMPL. Now we are only left with controllers and HTML views. So let us go ahead with controllers first. This is our registration controller, which is annotated with @controller annotation, which will mark it to serve different URL path requests. In this, first we have auto-wired the user service instance so that it will be injected at the runtime and we will be using the service class methods in this controller. Our first HTTP handler method is show registration form. This is a get mapping which will serve the HTTP GET request for /register URL. This is very simple as it will just return the view name when first time the registration page is requested from the browser. The next handler method is for post mapping, which will serve the HTTP post request for /register URL. This method will be invoked when user has filled up all the required details in HTML and want to submit the data to backend. In this, data will be received in model attribute user from HTML page. We are using the injected dependency of user service to call its save method, which will save the received user details into database. We can perform some basic validation on the data depending on our business requirements in service implementation before saving it to the database. This is all the logic we need in registration controller. So now let us move to the login controller, which will handle the login requests. Now, similar to registration controller, we have two login URL handling method, one for showing the login page for the first time, and second is to show the processing of login request when user submit it with email and password. And also we will be injecting user service via auto wiring in this case as well. So here in the first handler method, it is a simple get mapping with /login URL. So in this, first we are checking in the session if we have the current user present. If we already have the current user present, then we redirect the user to their dashboard URL. If not, then we present the user with simple login page. The second handler method serves post requests where email and passwords are passed in user object. Now using service class instance, validate user method is called, and if email and password is found, then the same user is returned. If the user is returned, then it will be set to session attribute of current user and user will be redirected to their dashboard. If user object does not return anything for the specified email and password, then an error message will be added and it will be redirected back to login. Now the last URL handler in login controller is /dashboard. In this, first we are checking if user is not logged in, and then we are adding an error in redirect attributes and redirect the user to /login with the error details. If dashboard is invoked after successful login, then HTTP session will have a current user. In that case, user model attribute will be set using current user and dashboard view will be returned. Now that is everything we need for login controller. Now just a very small controller is left, which is logout controller. In this, we have this single logout mapping for post requests. We are just checking if session is created, then invalidate it using session.invalidate and return to the login page again. With this, we are done with all Java level coding that we needed. Now we will be moving to the view part. As we are using Thymeleaf dependency in our application, so we will be using simple HTML pages along with Thymeleaf tags for server processing of HTML attributes. Let us first start with register.html. This is a very simple HTML page with some CSS written to make it look nice. Here we have one registration form where user details such as first name, last name, email and password will be filled. Then with the click of this register button, a post request will be sent to the backend at /register URL mapping along with the complete form data. Now to make use of Thymeleaf, first we need to add XML namespace like this. And then in the document, we will use this th to tag the HTML components for server level processing using Thymeleaf. If you remember, we are expecting an object of user entity at a registration controller. So what we will do, we will map this complete form to user object where we can individually tag each input value in the form to attribute of that particular object. For that, we are using th object and the name of the variable, which is user. After that, we are using th field for mapping HTML input fields to the object attributes. We also have this div to show if there are any messages returned in the redirect. And in the end, a small div which contains a hyperlink to login in case user is already registered. On the similar design, we have created this login.html where user will provide email and password and then request for the authentication. Similarly, in this view, we have a hyperlink for registration page in case user is not registered at. Next view page is dashboard.html. This will be called when user has successfully logged in. In this, we are printing the welcome message to the logged in user with their name and showing some static content as of now. This page contains a button for logging out the current session as well. This page will only be visible if user is logged in. Otherwise, user will be redirected to the login page if they try to access this page without logging in. Now, in the end, a very simple static HTML page that shows something is wrong if something which is not handled in our application occurs. Okay, so with this we should be good. Let me just start my Spring Boot application and then we will demonstrate all the features which we have coded. Now the application is started at port 8080, which is the default port if we do not provide any custom port in Spring Boot. Now before we start looking at the application, let us first check the database console. In the logs, we can see h2 console is available at /h2-console. Let us try and access the localhost at 8080/h2 console URL. Now we can see the console is up and running. In this, we need to provide the JDBC URL, which we can find in our logs or in application.properties. So here you can see the database is available at jdbc:/h2:file and path of the file where user detail database is present. After that, we just need to provide the username and password, which we have configured in our properties file, and then we can click on connect. Here we can see a user details table is already created because we have configured our Spring Boot application in such a way that it will scan for the entities which are present, and if the corresponding table is not present, then it will be created in the database. Let us write a simple select query just to see the data available in this table, and in the beginning we are expecting it to be empty. So here you can see the table is empty. Now let us move to our application. To access our application, let us first start with /register URL mapping. Here we need to fill all these details of first name, last name, email and password. After filling these details, we can click on register so that the request will be sent to backend for saving the user details. So here you can see a message is displayed that registration is successful. And as login page is also loaded, now we can log into this application using the detail which we have provided for email and password during the registration process. Now before login, let us first check the database table if we have received the details or not. So we will again execute that select star from user details table. And here you can see we are able to see the data. This is the email which we have submitted during our registration, and this is the password. Now let us move back to the login. Let us first try to log in with the wrong password. Here you can see an error message is shown that these details are not correct. Now let us log in with the email and password which we have used during the registration. Now we can see with the correct details, we are able to see the dashboard where user related details is also shown in addition to some static data. Here you can see in the welcome message, we are printing the dynamic first name of the user who has logged in. So here the first name was lazy programmer that we have configured during the registration time. So that is getting printed in this dashboard. Now at this point, an HTTP session is created, and if we try to access the login page again, it will be immediately redirected to the dashboard page. Now let me try it. So here you can see it is immediately redirected back to the dashboard because a session is already present. Now let us log out. Now at this point, the session is invalidated as per the logic written in our logout controller. So now if we try to access the dashboard URL, it should give me an error. Here you can see that it is redirecting me to login page with an error which states that I'm not logged in, so I cannot access the pages where user must log in first to access. So these were all the pages that we have developed and all the business logics for login, registration and dashboard. That was it for today's video. If you find it useful, please share it with your friends and also give us a like and subscribe to the channel if not done yet. I will see you in the next video with some more interesting topics from Spring MVC. Till then, happy coding!